Mole conversions. In our last video, we established that a mole was a number, just like a pair of scissors would be two, or at least two cutters right here. And a dozen styrofoam balls would be 12 styrofoam balls. A mole is also a number, but it's a really big number, about 6 times 10 to the 23rd, a little bit more specifically, 6.022 times 10 to the 23rd. Now, we also established that there were a mole of these water molecules, H2O molecules, in this amount of H2O, which would be a mole of H2O, which would be 18 grams of H2O. How did I figure that out? I looked at the periodic table and we established that hydrogens each weigh 1 gram. There were 2 times 1 would be 2 grams, and oxygen weighed 16 grams. 1 times 16 was 16 grams. So 18 grams was the total amount. 1 mole of water molecules weighs 18 grams, or 6 times 10 to the 23rd molecules of water weighs 18 grams. All right, let's look at mole conversions, and let's just think about this. Okay, see something here that can help us, but let's take a look. If 1 mole is 18 grams, my guess is that 2 moles of water would be double that, or 36 grams. What did I do? I just went from here to here, 2 moles times my molar mass of 18. So it'd be 2 times 18 equals 36. So to go from moles to grams, we multiply by the molar mass. If it's water, the molar mass would be 18. If it's iron, it would be a different molar mass. So this is the specific to the substance you're using. Let's say I had 36 grams of water. How many moles do I have? I would do just the opposite. I'd take the 36 grams that I have, divided by 18, which is the molar mass, and I'd be back to 2 moles. So 2 moles is equivalent to 36 grams. 36 grams is equivalent to 2 moles for water. All right, let's try something different. We said 1 mole was 6 times 10 to the 23rd molecules of water. What would 2 moles be? It would be twice as many molecules. So instead of 6 times 10 to the 23rd, it would be what? 2 times 6 times 10 to the 23rd, which would be about 12 times 10 to the 23rd molecules, which also comes out to be 1.2 times 10 to the 24th molecules. So going from moles to molecules, if we're dealing with a compound, or moles to atoms, if we're dealing with a single element, or moles of eggs to actually number of eggs. If we were talking about eggs, it doesn't matter. This moles and number, we'd multiply by 6 times 10 to the 23rd. What if I were told I had 1.2 times 10 to the 24th molecules of water? How many moles of water would I have? I do just the opposite. I take the 1.2 times 10 to the 24th, divided by 6 times 10 to the 23rd, and I'd be back to about 2 moles right here. So going from moles to atoms or molecules or whatever you're talking about, you multiply by 6 times 10 to the 23rd. Going from atoms or molecules back to moles, you divide by 6 times 10 to the 23rd. So we're going to do some mole train problems. And really the big thing when we do these is identifying your starting point, ending point, and then solve the problem. Okay, this is supposed to look like a little bit of a train. I don't know if that works that good, but I think it sounds like a train. Listen. All right, we have our mole train. All right, so I'm going to look at an example. How many moles of H2O are in 100 grams of H2O? So if I were to solve this problem, what do I know? My starting point is I have 100 grams of H2O. What am I trying to find out? I'm trying to find out how many moles of H2O. So I'm just going to kind of model this. I know the grams. I know I have 100 grams. I'm trying to get to moles. So what does it tell me to do? It tells me to divide by the molar mass. So I'm going to take 100 divided by the molar mass of 18, and that's going to get me to moles. I'm going to model this showing dimensional analysis. I have 100 grams I start with. What's bigger, 1 mole or 18 grams? It's an equivalent. These are the same. 1 mole of water and 18 grams of water are the same. So grams is on top here. It goes on the bottom here. Moles goes on top here. And I convert from grams to moles. It's 5.56 moles. The next question says, how many molecules of water are in 100 grams of H2O? So this time, I'm starting way here at 100 grams, and I'm trying to find molecules. It looks like I'm gonna have to do 2 steps. I'm gonna go grams to moles, and then moles to molecules, because that's what we're talking about here. The first step, it looks like I'm gonna divide by the molar mass of 18. The next step, I'm gonna multiply by 6 times 10 to the 23rd. Let's look at how that looks. 100 grams, grams goes on the bottom, moles goes on top. There's 18 grams in a mole, so you divide by 18. That would actually give us to where we were before. That gives us 5.56 moles if we stop there. But then we say there's 6 times 10 to the 23rd molecules per 1 mole. So we just multiply that there, and we end up with 3.334 times 10 to the 24th molecules. So notice I divided by the molar mass, multiplied by 6 times 10 to the 23rd, because our mole train told us to do that. We started at grams, 100 grams, divide by the molar mass to get to moles, multiply by 6 times 10 to the 23rd. One more problem like this, and it says, what is the mass of one H2O molecule? It's one itty bitty molecule. Now we said a mole, or 6 times 10 to the 23rd, weighs 18 grams. One molecule, I'm guessing, weighs a lot less. So what am I going to do? I'm going to actually start here with 1, and I'm going to divide by 6 times 10 to the 23rd to get to moles. And then to go from moles to grams, it looks like I multiply by the molar mass. So let's try this here. 1 molecule. Let's bring this up so you can see this a little better. Okay, so I got 1 molecule. I'm going put 6 times 10 to the 23rd molecules on the bottom and moles on top. So I'm dividing by 6 times 10 to the 23rd. And then I'm going from moles to grams. So I multiply, what do I multiply by? The molar mass of 18. Now, what is that going to give me? That's going to give me a really small number. Does that mean this is like 0.00022 zeros, 299 grams? Okay, we don't have a scale that can measure something that small. So 1 molecule is going to be really, really, really small amount in here. Okay, so let's just do an example from page, I think you're going to have to do pages 6 and 7. So let's do an example or two. It says, how many atoms are present in 4 moles of any element? The first thing is if I said how many eggs are in 4 dozen eggs, it would be the same number as how many pencils are in 4 dozen pencils. Okay, so the element really doesn't matter. All we're doing is we're starting at moles and we're converting to atoms in this case. So we're going to take our moles, and it looks like we're going to multiply by 6 times 10 to the 23rd to get to the number of atoms. We're going from here to here, starting and ending point. So I'm going to write this out, and I'm going to say 4.0 moles, and then I'm going to times that by, and what is it? It's going to be 1 mole. I might do this actually. I'm going to put moles in the bottom. Maybe I'll draw this here. I'll say 1 mole on the bottom. And I'm going to say atoms. Oh, how many atoms are in a mole? We know it's 6 times 10 to the 23rd. I have 2 sig figs, so I'm going to say 6.0 times 10 to the 23rd. It will give me the same number. And I'm going to do this and do a 2, 3 here. and I multiply that through, and I believe I'm going to get 2.4 times 10 to the 24th. So I know it's going to be a number bigger than 6 times 10 to the 23rd because I have 4 of them, and it is a little bit bigger. It's 10 to the 24th right here. That would be 4 times bigger. So get your starting point, go to your ending point, and I probably should say this, how many atoms. I would say this would be atoms right here. And put my units on there. Show work, proper units, proper sig figs. If I have 2 figures here, I'm going to end up with 2 significant figures right here. Okay, I might do one more example, and I think I'm going to go to example number 5, and that's down here. And this one says, determine the number of moles in 160.65 grams of sulfur. So I might write down what I know. I'm going to write down what I'm given, 160. I'm going to clear this other one out, I think, so it's not messy. I'm going to try that again. I'm going to say 160.35 grams. And then I'm going to times it by something. And I think I'm going to go to my chart and just look at this right here. So I'm going to scroll back and look at my chart. I'm starting with grams right here, and I'm trying to get to moles. How do I go from grams to moles? It says to divide by the molar mass. We're talking about sulfur, so I got to look up sulfur on the periodic table, and I think I'm going to find that right up here. Now, notice usually rounding to the nearest tenth is fine. Because I have so many figures, if there's 5 figures there, I'm going to use them all. I'm going to use 5 figures here. So I'm going to say 32.065 in this one right here. Okay, so I got to find that and go back. And I'm going to say times, I'm going to put 1 mole on the top. And I'm going to put 32.065 grams right here. And I divide that through, and it looks like I'm going to get a number bigger. I don't know, it looks like it's going to be about 5 something. And I think if I want to keep all my figures, I think it ended up getting 5.0006, I believe, and that would be moles. Okay, the big thing is to get the concept here. I had 5 figures here, so that's why I kept 5 figures in here. But the big thing is understanding the concept. I'm going from grams to moles. So grams goes on the bottom, moles goes on the top, and I end up dividing by the molar mass. And that's where I get my answer right there. So that is the lesson for today. And ride your mole train. Again, when you do a problem, notice where you're at, notice what you're trying to get to, and then go through your conversions from there. All right, good luck. Work with pages 6 and 7. I think you get some practice opportunities. Thanks.